Hey everybody, this is Larry. This is me going with Q3. Let me make this bigger. The Leetcode. This is problem 3 of the weekly contest 379. Maximum size of a set after removal. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So this one is kind of very tricky, but the way that I think about it is just case analysis, right? And yeah, and case analysis and greedy in a way. But I think the critical part is just being able to have a better visualization about this problem, and once you do that, I think it should be fine. I don't know that I need this actually, so let me do 256. Is that right? Yeah. Okay. But yeah, the idea is going to be greedy. Instead of thinking about removal, I think about adding. I think that is the critical part that allows greedy to yeah, I think that for me allows me to kind of not prove greedy, but you'll see that in a second. That the greedy solution is a little bit a little bit of a like it allows me to kind of build intuition for it. So let's go over the code. Basically, I have two sets because removing the duplicate numbers are for free, right? Like there's no reason to keep them. As we said, the way that I would think about it is add up to half the numbers from each one so that they're new. So that's basically it. So I have S1 is equal to S2, or S1 and S2, they're both the set numbers. I have the intersection, that's the set intersect, the numbers that are in both sets. And then now I just keep unique 1 and unique 2, right? So now the number of things in U1 and U2 are unique from each other, right? So they're distinct sets, and you always want to keep them up to n over 2, which is what I have here. But you always want to keep as many as you can. And then here, now for the intersection, then intersection means that the numbers can be in both sides, and you have to basically make a decision to which side you want, right? And of course, if you do this naively, it's going to be 2 to the n, or 2 to the some crazy number. But this is where the adding part is better than the removal part, because if you figure out which one to remove, you may remove something from one that in the future you need to keep for the other one or something like that, right? But adding is easier because now you know that as long as you have less than n over 2, it doesn't matter which one you add it to, because all the numbers that you're going to add are going to come up later, right? So that means that yeah, you can think about it as adding it in a way that it doesn't matter, or that it will be it won't change the result, not that it doesn't matter. So yeah, so if adding this number to set 1 is less than n, then we can add it to set 1. Otherwise, we put it in the second unique set, and then yeah, and then otherwise we just take half, or at most half of n over 2, or the number of unique things, and also the same for the second part. And that's pretty much it. This is going to be linear time, linear space. This is linear time. 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 So yeah, a lot of linear time things over here. And space, obviously, using the sets, or going to be linear space. So yeah, that's pretty much it. So the core idea is greedy, and just kind of, but from addition instead of removal. And you could kind of figure out that, and you could kind of, because you can keep on adding as long as it doesn't reach the upper bound, it doesn't really matter where you add it. You could like flip these two and it'll be fine, for example, as long as you flip the constraints and everything. But yeah, cool. That's all I have for this one. Let me know what you think, and yeah, you could watch me solve it live during the contest now. Something like that. Okay. That was silly. Okay, let's finish this. So you move half from the beginning, half from the end. Okay. Is it greedy? A lot of numbers. Greedy makes sense, but that might not be all of it. Okay, so basically, we need to sort, right? Okay, right. If press 1. We just return the length of S1 because we can't do anything about it anyway. Otherwise, I think this is the good case, right? Maybe. Yeah. Then the question is, if this is they're both big enough. Okay. Whereas in the second, is you gotta right. Both too much. I think it's just case analysis, but I'm like, my brain is not really working well. Otherwise, okay, you have 6 and you have 2. How do you get 5? Right? Do you just, we always want to remove it from the thing that's from the more. What if they both have more than half? If they both have more than half, it's, then you have a choice. So this is the unique of part 1. This is unique of part 2, right? And then it is just about getting it up to half, right? So then now, what is that math? I'm putting it back. Each of these belongs to both, so it doesn't really matter what, right? So, okay. Did I get this right? I meant this. Two, 6, 6. Ooh, 5. Why did I get 6? Okay, what to do? Why? Oh. Oops. Why? Tell me why. Oh, I see. That makes sense. So that means that, okay, fine. All right. They should be unique anyway. Oh, there should be no in this section. Is this right? Yeah, YOLO. Okay, good. How am I doing? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this forum, this contest, everything in between, the explanation, whatever. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.